8 today. All right, so 83. Again, it's asking me to, now read the instructions. It does say for each of the following, find f prime of x. So they're asking you to take the derivative. Okay? So since they're asking me to take the derivative, I can simply go, that's just going to be x to the 4th plus. Imagine doing that any other way. It would be really awful. Take the integral of x to the 4th. You can't do it. You could not do that problem. You had to do it the raw way. Okay, moving forward. What do we try this without our new rule? So everybody go ahead and do the next one without our new rule. In other words, we're going to go back, we're going to take the integral, and we're going to take the derivative of it. We're going to do it the hard way again.
Yeah, it is.
Is everyone working on that? So, raised to a power, divide by the power I get, plus c. As always, the c is not going to matter. From c to x, so it's going to go away and end up with x to the 3rd. Agreed? Now I want you to do it for the one below, and this one's going to give you something weird, which we will fix. Three, one, go. All right. Quality of this recording is going to be excellent. 2 to x squared, t to the 3rd dt. So it feels like, what does it feel like the answer should be, Mr. Biboulet?
Feels like x to this.
X is 6, and that's a fine guess. It's wrong. We need to know why. No, seriously, that's what you should guess. And that's what's going to happen on the test. You're going to look at this guy and just plug it in, right? So you need to pause a moment. When you see this, there's something weird about this we need to worry about, right? That's what we're going to do. So that's exactly what we want to do. So we look at this, we go, all right, how do I do this problem? I'm going to integrate. So I go c from 2 to x squared, agreed? Now I'm going to plug in that x squared. I get x to the 8th over 4 plus c minus 2 to the 4th over 4 plus c, right? C's don't matter. I'm wasting time. I look at this. This is not going to matter either, is it? It's a number. So that all goes away. I get x to the 8th over 4. And I'm going to take the derivative with respect to x. Agreed? Now I'm going to take the derivative of this. So what am I going to get?
2x to
You did all the steps in your head simultaneously. I'm with you. Hold on. So yeah, let's do it. 2x to the 7th. Agree. I'll be there in a moment. Okay, got it? Agreed? Okay, so it did not turn into this. It turned into this instead. Agreed? So what do? How did this happen? Putting x squared on there has messed this up in the following way. How? What's extra? Blaze, what's extra?
the square.
The
power.
I've got a power and a 2, right?
Yeah.
So I can rewrite this as x to the 6th times 2x. Could I not? Got any great ideas for where that 2x could have come from? How does an x squared give me 2x? So derivative. The chain rule. Remember, we take the derivative with respect to something that we didn't expect. We have to tack on the chain. When it's x, we just plug it in. If we want to do anything other than x up here, what do we do instead? We do it just like we would, and we tack on the derivative, the chain. Because we took the derivative with respect to the wrong thing. Does that make sense? It's magic. Make sense, though?
Yeah.
The reason why that really happens is because we do not apply the x squared until after we've done the integral. So we're not taking the derivative of the integral. We're simply, the derivative of the integral part is contained. We still, this is another, the derivative is actually of something slightly different. Agreed? And that's why I have to tack on the chain. Make sense, Blaze? All right, flipping it over, you've got problems 85 through 86, which sounds like not too many problems, but it's a lot more than you think.
Yeah, I love those problems.
We're still doing the same one, Davina? Davina, we're still doing the worksheet from yesterday, or Thursday, whatever it was. So that'd be 4x plus 9. The answer to that. Next one, I'll give you finally something interesting. Now remember, the instructions say find the derivative of these functions. The functions are integrals already. So this is going to be sine x times the derivative of the inside times the derivative of that thing, which is cosine x.
On the example, when we did it, did you
Yes.
plug in the x squared?
We plugged in the x squared. Remember, back when I asked Blaze, first thing I asked him, I said, what should it be?
Yeah.
If I plugged in the x squared, I would get x to the 6, would I not? And then we did it the hard way, and we got this instead. And went, oh, crud, didn't work. A rule didn't work. So then I separated two piles. This is what it should have been if I just plugged it in, times the chain, because I plugged in the wrong thing.
Yeah, okay, yeah, I got it.
Right?
Yeah.
And so we're doing the same thing here. We're taking just plugging in the sine, and then since I use sine instead of x, I'm tacking on the derivative of sine, which is cosine x.
I got it.
Excellent.